Hello everyone, I am Mary Swarnalatha, working as an assistant professor in the Department of Electronics and Communication Engineering. In today's lecture, we are going to discuss about expected value of a function of multiple random variables, correlation, covariance, and correlation coefficient. In the previous lectures, we have seen expectation of a single random variable, that is nothing but operations on a single random variable. Now, the same concept we are applying to the multiple random variables. So, for example, first consider x and y are two random variables with a joint density function fxy of x comma y. Now, consider g of x comma y. So, what is this? This is a function which is of two random variables x and y. What is g of xy here? So, g of x comma y, it is a function of the two random variables x and y. Now what you have to calculate? You have to calculate the expected value of a function of the two random variables x comma y. Nothing but you have to calculate expectation of g of x comma y. So it is nothing but what? Expectation of operations on multiple random variables. Since we are considering more than one random variable, so it is called as what? Expectation of multiple random variables. Now we have seen the random variables have been two types. One is continuous random variables and the second one is what? Discrete random variables. Now if x and y are continuous random variables, then expectation of g of x comma y is equals to what? How many random variables here? You have two random variables. Therefore, with respect to x, one integration, with respect to y, one more integration, and the limits are from minus infinity to infinity. So, expectation of any function is what? That function. What is the function here? G of x comma y into the joint density function. What is the joint density function of the two random variables? fxy of x comma y. Therefore, here fxy of x comma y into what? Dx into dy. So, this is the what? The expectation of two random variables in case of the two random variables are continuous random variables. Now, for discrete random variables, how can you write down the expectation of the two discrete random variables? In place of integration for discrete random variables, what can you obtain? We will write down sigma. Because for continuous, the summation nothing but integration, and for discrete random variables, the summation nothing but what? Sigma. So therefore, sigma g of I comma j, let us say I am taking two variables I and j. So sigma g of xi comma yj into fxy of xi comma yj, or else nothing but what? Sigma I and sigma j. What are the limits of here? I and j? I equals to minus infinity and j is also from minus to infinity. So therefore g of xi comma yj into what is fxy of xi comma yj? Nothing but the joint density function at a particular value is nothing but what? The probability only. Therefore, this is nothing but what? P of xi comma yj only. Therefore, the expectation of multiple random variables for two random variables which are continuous, this is a formula to calculate, and the expectation for two discrete random variables, the function of two discrete random variables, so this is a formula to calculate. Now, you have written for two random variables. The same thing you are applying for what? N random variables. So, let us consider x1, x2 and so on. Xn are n random variables. So, previously you have taken only two random variables x and y. Now, instead of two, now we are taking how many random variables? We are taking n number of random variables. And what is this g of x1, comma, x2, comma, and so on, xn? Nothing but what? it is a function of these n random variables. So what is this? Nothing but g of x1 comma x2 and so on xn. It is nothing but what? It is a function of these n random variables. Now what you have to write down the expression? You have to write the expression for what? Expectation of a function of these n random variables. And nothing but what? G of x1, x2 and so on xn. Now, in case of continuous random variables, how can you write down the expectation? How many random variables you have here? N random variables. Therefore, how many integrations you are going to get? N number of integrations. So, x1 is from minus to infinity and x2 is also from minus to infinity and so on. xn is also from minus to infinity. So, expectation of any function is what? That function you have to write down. What is the function here? G of x1 comma x2 and so on xn into the joint density function. Since you have more than one random variable, you call it as what? The joint density function. What is the joint density function of these n random variables? Nothing but what? F x1 x2 and so on xn of x1 and so on xn into what? dx1 dx2 and so on dxn. So, and similarly, we can write down the expectation of a function of n random variables, and these n random variables of which type? They are of discrete random variables type. Then what is the expectation of a function of n discrete random variables? Is given by what? x1, x2 and so on xn is equals to, for continuous random variables, we are taking the integration as summation. For discrete random variables, the summation nothing but what? Sigma. So, sigma, how many times are going to get? N number of times. Let us say, I am taking I1, n variables. I1 previously have only 2 variables. I am taking as what? I1, I2 or else I can take it as I and j. Since you are having n random variables, I take here n number of variables like I1, I2 and so on In. So, I1 equals to minus to infinity and I2 equals to minus to infinity and so on. And is also from minus to infinity. G of xi1. What is the first one here? If you have 2 random variables, for 2 random variables, the first variable is I, second variable is nothing but j. So, g of xi comma yj. If you have n random variables, so xi1 comma xi2 and so on xin into what? You can write down directly the probability function. So, what is the probability mass function here? The joint probability function P of xi1 comma xi2 and so on xin. Therefore, this is the expectation of a function of n discrete random variables, and this is what? The expectation of a function of n continuous random variables, and it is a expectation of a function of 2 discrete random variables, and it is the expression for expectation of a function of 2 continuous random variables. Now, next we are going for what? Correlation. So, what is a correlation? Relation nothing but what? Similarity. How they are related. So, correlation is nothing but what? Measuring the similarity. So, correlation between 2 random variables. It means measuring the similarity between 2 random variables is called as correlation. Now, what is the correlation between 2 random variables x and y? Is nothing but what? Correlation, nothing but represented by R symbol. So, correlation between what? 2 random variables, or the random variables names here? X and y. Therefore, Rxy is equals to what? This is nothing but the second order joint moments about the origin M11. So, it's nothing but what? Expectation of x into y. So, this is a formula for what? Correlation between 2 random variables x and y. Now, if x and y are continuous random variables, then what is the correlation formula? Rxy is equals to expectation of xy is equals to how many random variables you have? 2 random variables. Therefore, we have to take here the double integration. X is from minus to infinity and y is from minus infinity to infinity. Expectation of any function is what? That function you have write down here. Previously here you have g of x comma y. In place of g of x comma y, what do you have here? Xy. Therefore write down here x into y into the joint density function of these two random variables. How do you represent by f x y of x comma y into what? Dx into dy. So this is for what? Continuous random variables. And similarly, if x and y are discrete random variables, then how do you write down the correlation between these two random variables is nothing but what? Expectation of x comma y is equals to sigma I and j. What is I limit here? You can take from minus into infinity and j is also from minus into infinity. xi into yj. Here xy. Here discrete variable, discrete values. Therefore, I write down what? xi into yj into. In place of this, I write down the joint probability function. Nothing but what? P of xi comma yj. So, what is P of xi comma yj? It's nothing but what? The joint probability such that the random variable takes xi value and the random variable y takes the yj value. So instead of representing by p of x equals xi comma y equals yj, simply you can represent by what? P of xi comma yj. And therefore, the correlation between two random variables x and y is given by expectation of x comma y. This is nothing but what? The second order joint moments about the origin. Now, if you are taking different conditions, what is the first condition you are taking? If x and y, the random variables are orthogonal random variables. What is the first case I am taking? I am taking the first case as if x and y are orthogonal random variables. Orthogonal random variables. Then, what is the correlation between those two random variables? Rxy, nothing but expectation of xy. What is that value is equals to 0. Therefore, for two orthogonal random variables, what is the correlation is equals to 0. There is no similarity for two orthogonal functions. Therefore, their correlation is equals to 0. The similarity is 0. Therefore, the correlation is equals to 0. And second case we are taking, if x and y are uncorrelated, the random variables x and y are uncorrelated random variables. If x and y are uncorrelated random variables, then what is Rxy? Nothing but P of xy. Expectation of xy is equals to what? Expectation of x into expectation of y. Or else x bar into y bar. Therefore, if two random variables are uncorrelated, then the correlation between those two random variables is equal to the product of their means. Nothing but u of x into u of y. So, and if x and y are uncorrelated, then you can say that they are also statistically independent random variables. So, if x and y are uncorrelated, then you can say that they are also statistically independent random variables. So, these are some special cases of correlation. And the next one is what? Covariance. So, what is correlation? Measuring the similarity between two random variables. Then, how we are represented by Rxy. Similarly, what is the covariance? Can represent by what? Cxy. How they are related with respect to about the mean, nothing but what? Covariance. So, then what is the covariance formula here? Cxy, Rs can represent by what? Sigma xy, Rs can represent by COV of x comma y. So, there are different representations for representing what? Covariance. C symbol Rs, sigma, Rs can represent by COV. So, Cxy, sigma xy are COV of x comma y. So, these are the different representations for covariance symbols. Now, what is the covariance of Cxy? Nothing but what? It is called as what? The second order joint central moment. Nothing but mu11 is called as what? The covariance. So what is that? Nothing but what? Expectation of x minus x bar into y minus y bar. This is called as what? Covariance. Okay. Then, so this is the formula for what? Covariance between two random variables. Now, if you simplify this, then what can you obtain here? Then Cxy is equals to expectation of. So here x minus x bar into y minus y bar. Just multiply these two terms. Then what can you obtain? X into y. So x into y. Then x into minus y bar. Nothing but what? Minus x into y bar. Next minus x bar into y. Nothing but minus x bar y. Next minus x bar into minus y bar. You'll get plus x bar into y bar. Now what is the expectation of x plus y? Or expectation of a plus b equals expectation of a plus expectation of b. And here also same. So I'm going to write down this as what? Expectation of xy minus expectation of x into y bar minus expectation of x bar into y plus expectation of x bar into y bar. Now what is the expectation of xy? This is nothing but what? The correlation Rxy. Therefore, how can I write down this as what? Expectation of xy nothing but the correlation between two random variables x and y. So next what do you have here? Minus expectation of x into y bar. What is y bar? It is the mean of y, which is a constant. So you can bring it outside. Then how can I write down this as what? Minus y bar into expectation of x. What is the next one you have here? Minus expectation of x bar into y bar. What is x bar? So x bar is nothing but what? Mean of x, which is a constant value. And what is y bar? Nothing but expectation of y. Nothing but is also a constant value. So therefore, this x bar you can bring it outside. Then how can I write this as? Minus x bar into expectation of y. Next what do you have here? You have plus expectation of x bar into y bar. X bar is constant, y bar is also constant. Then the expectation of the statistical average or expectation of any constant is the constant itself. Therefore, here x bar into y bar. That equals to expectation of x into y minus y bar into what is u of x? Nothing but x bar only. Minus x bar into y bar plus x bar into y bar. So that equals to what? Expectation of x into y. Here this will be get cancelled. Then you'll get minus x bar into y bar. Therefore, this is a one more expression for covariance. What is first one? Expectation of x minus x bar into y minus y bar. What is other form for covariance expression? Cxy is equals to u of xy minus x bar into y bar. This is the second form of the covariance function. And what is u of xy? It is nothing but the correlation Rxy. So Rxy minus x bar into y bar. So this is what? One more representation of covariance. So next one is, I am taking the different conditions. What is the first condition? I am taking x and y are orthogonal. X and y are what? Orthogonal random variables. So if x and y are orthogonal random variables, then what is the correlation Rxy is equals to? Nothing but u of xy is equals to 0. Then what is the covariance formula in terms of Rxy? The correlation Rxy minus x bar into y bar. Therefore here Rxy minus x bar into y bar. If they are orthogonal, what is Rxy? The correlation is 0. Therefore 0 minus x bar into y bar. Therefore if they are orthogonal, then the covariance between those two orthogonal random variables nothing but minus x bar into y bar. What is x bar? Mean of x. And what is y bar? Mean of y. This is the first case. And what is the second case? If x and y are uncorrelated random variables. If x and y are what? Uncorrelated random variables. For uncorrelated random variables, what is the correlation? Previously I have seen Rxy is equals to what? e of x into e of y. What is e of x? That is nothing but x bar. And what is e of y? That is nothing but y bar. Therefore, what is Rxy for uncorrelated x bar into y bar? Then what is the expression for Cxy? Rxy minus x bar into y bar. If they are uncorrelated, what is the correlation? X bar into y bar. So, x bar into y bar minus x bar into y bar. Therefore, if two random variables are uncorrelated, then the covariance is equals to 0. And you can say that they are also statistically independent. Now let us see the properties of covariance. What is the first property? The variance of sum of two random variables x and y is given by variance of x plus y. What they have given? Variance of sum of two random variables x and y. So variance of x plus y is equals to what? Variance of x plus variance of y plus 2 into covariance of x comma y. So let us prove this property. So we know that what is the variance of x formula? Sigma x square is equals to what? Expectation of x minus x bar whole square. So if you simplify this, what can you obtain? E of x square minus x bar square. Now this is the formula for variance. Now what you have to calculate? You have to calculate what? Variance of sum of two random variables x and y. Therefore, you take the LHS part. So what is that? Variance of x plus y is equals to what? Sigma of x plus y whole square. That is equals to what? Expectation of, in place of x, what do you have here? X plus y. Therefore, x plus y minus, in place of x you have x plus y here. Just compare these two. Then x plus y bar whole square. So if you simplify this, what can you obtain here? Expectation of what? X square. What is x here? In place of x you have x plus y. Therefore, x plus y whole square minus x plus y whole bar square. Then what is expectation of x plus y whole square? Nothing but what? Just write down the a plus b whole square formula. Then what can I write down here? A square, nothing but x square plus y square plus 2xy minus. So what is x plus y bar is nothing but what? Expectation of x plus y only. Okay. So what is expectation of x plus y? Nothing but what? E of x plus e of y. Nothing but what? X bar plus y bar. Therefore, how can I write this as what? X bar plus y bar whole square. Then you can write, how can you write e of x square plus y square plus 2xy, e of x square plus e of y square plus 2 into e of xy. After that, x bar plus y bar whole square, a plus b whole square formula. So a square plus b square plus 2ab. Now we can write down this expression as what? E of x square plus e of y square plus 2 into e of xy minus, what do you have here? X bar plus y bar whole square. So write down the formula of a plus b whole square formula. Then you can write down a square, nothing but x bar square plus y bar square plus 2 into x bar into y bar. That equals to what? E of x square minus e of y square. This is not minus here, plus e of y square plus 2 into e of xy minus x bar square minus y bar square minus 2 into x bar into y bar. That equals to what? You can rewrite this expression as what? E of x square minus x bar square plus e of y square minus y bar square plus, if you take 2 common, e of xy minus x bar into y bar. Therefore, I don't here e of x square minus x bar square plus e of y square minus e of y square minus y bar square plus, take 2 common from these two. Then you can write down e of xy minus x bar into y bar. Now what is u of x square minus x bar square? That nothing but what? Variance of x. What is variance of x? U of x minus x bar whole square. If you simplify this, can write as what? U of x square minus x bar square. Therefore, this is nothing but what? Variance of x. And this is nothing but what? Variance of y. Plus 2 into. So what is u of xy minus x bar and y bar? Previously I have seen nothing but covariance of xy. Therefore, nothing but what? Variance of x plus variance of y plus 2 into covariance of x and y. So this is nothing but your RHS. Therefore, variance of x plus y is equals to what? Variance of x plus variance of y plus 2 into covariance of x into yx comma y. And what is the second property here? If x and y are independent random variables, then covariance of x comma y is equals to 0. So what is the covariance of x comma y formula actually? So expectation of x minus x bar into y minus y bar. If you simplify, what can you obtain here? U of xy minus x bar into y bar. Or else can write what is u of xy? The correlation rxy. So x bar into y bar. So if x and y are statistically independent random variables, then what is u of xy is equals to u of x into u of y. So what is u of x? Nothing but x bar. And what is u of y? Y bar. Therefore, what is the covariance of x comma y is equals to, what is u of x if they are independent? X bar into y bar. Therefore, x bar into y bar minus x bar into y bar equals to 0. Therefore, for independent random variables, the covariance is equals to 0. And what is the next property? If x and y are independent random variables, then variance of x plus y is equals to variance of x minus y is equals to variance of x plus variance of y. So previously I have seen what is the variance of sum of two random variables? We have seen it as what? Variance of x plus variance of y plus 2 into covariance of x comma y. Similarly, so what is the variance of x minus y? Nothing but what? Variance of x plus variance of y minus 2 into covariance of x comma y. So what they are given that? They are given that given x and y are what? Statistically independent random variables. If they are statistically independent random variables, then what is covariance is equals to 0. So if the statistically independent random variables, what is the covariance here? It is equals to 0. So substitute here covariance is 0. Therefore, then what is the variance of x plus y is equals to variance of x plus variance of y. And similarly, what is the variance of x minus y is equals to variance of x plus variance of y only. It means if they are independent random variables, then variance of x plus y is equals to variance of x minus y. That is nothing but the variance of sum of two random variables is equals to the variance of difference of two random variables. And what is the next property here? Covariance of x comma y is always less than or equals to sigma x into sigma y. What is sigma x? Standard deviation of the random variable x. And what is sigma y? Standard deviation of the random variable y. Now how do you prove this one? So if I want to prove this, first consider expectation of y minus mu y. What is mu y here? There is nothing but y bar only. Nothing but expectation of y only. Minus a. What is a here? It is any real constant into x is nothing but random variable here minus mu x. So what is mu x? Nothing but mean of the random variable x. Nothing but x bar or also e of x. So what is this your expectation? You are squaring and then you are calculating the average. So if you are squaring and then if you calculate the average, that will always be a positive value only. There is nothing but it is always greater than or equals to 0. So therefore, the mean square value is always positive. That's why We are writing this as what? Greater than or equals to 0. Then expectation of, this is like a minus b whole square. So let us say this is nothing but a and this is nothing but what? B. So a minus b whole square formula can apply. Then how can I write down this as what? Y minus mu y. So in place of mu y, simply write down as y bar because mu y equals to y bar only. So y bar whole square plus a square into x minus x bar square minus 2ab. So 2 into a. What is a here? Y minus y bar into, and what is b here? A into x minus x bar. So what is this value? So this value is greater than or equals to 0. It equals to expectation of, how can I write this as what? Y minus y bar whole square plus a square is constant. If you can bring it outside, a square into expectation of x minus x bar whole square minus 2 is constant, we get outside, 2 into expectation of, here a is also constant, bring it outside, minus 2a into, you can write this as what? X minus x bar into y minus y bar. So which is greater than or equals to 0. Now what is the expectation of y minus y bar? Nothing but what? The variance of the variable y only. Plus a square into, what is the expectation of x minus x bar whole square? Nothing but the variance of the variable x minus 2a into. So what is the expectation of x minus x bar into y minus y bar? That is nothing but what? Covariance of x comma y. So this is what? Greater than or equals to 0. Now that implies, so sigma y square plus, here take sigma x square common. Then what can happen here? A square minus 2 into, I am writing this as what? Covariance of x comma y, 2 into a into covariance of x comma y by, what do you have here? Sigma x square. So greater than or equals to 0. So what you got here? Sigma y square plus, if you take sigma x square common, what is the expression we got? A square minus 2a into covariance of x comma y by, this is a. So 2a into covariance of x comma y by what? Sigma x square. So what is this value? Greater than or equals to 0. So that implies sigma y square plus sigma x square. This is like a square minus 2ab. So you have to write down formula for a minus b whole square. Then what can you do? Write down here a square minus 2 into a into covariance of x comma y by sigma x square. So what I am doing here? I am adding here covariance of x comma y by sigma x square whole square. What I am doing here? I am adding this term and then subtracting the same term. So COV of covariance of x comma y by sigma x square whole square. This is what? Greater than or equals to 0. That implies sigma y square plus sigma x square into, this is like what? A square minus 2ab plus b square. So what is a square minus 2ab plus b square? A minus b whole square. Therefore this is nothing but what? A minus b. What is b here? COV of covariance of x comma y by sigma x square. So a minus b whole square. So minus, what do you have here? Covariance of x comma y by sigma x square whole square. What is this value? This is nothing but greater than or equals to 0. Then how can we write down the expression? What is that expression we got? Sigma y square plus sigma x square into, what is the expression we got? A minus covariance of x comma y by sigma x square. This is also square. So covariance of x comma y by sigma x square whole square minus covariance of x comma y by sigma x square whole square. This is the expression we got previously. So which is greater than or equals to 0. So that implies sigma y square, and here sigma x square into what is here minus CO covariance of xy whole square by sigma x square whole square. Then how can I write this as sigma x square into a minus covariance of x comma y by sigma x square whole square minus here sigma x square into what do you have here? Covariance of x comma y by sigma x square whole square greater than or equal to 0. Then what can you obtain here? Sigma y square. Here sigma x square and sigma x square whole square. Then what can you obtain here? Covariance of x comma y whole square by sigma x square plus what do you have here? Sigma x square into a minus covariance of x comma y by sigma x square whole square greater than or equal to 0. Now here take sigma x square LCM. Then what can you obtain here? Sigma x square. Then how can I write down this as what? Sigma y square into sigma x square minus covariance of x comma y whole square. Now the second term here, sigma y square into a minus covariance of x comma y by sigma x square whole square, which is greater than or equal to 0. Now if you observe this, what is sigma y square? It is a variance. Variance is always positive. Therefore this is always positive. And what is a minus covariance of x comma y by sigma x square whole square? This is square. So you are squaring that. Therefore this term is also positive. Therefore these two are positive. And in order to make this condition satisfied, this equation has to be satisfied. This has to be what? Greater than or equal to 0. Therefore, in order to make the condition satisfied, what is the condition here? This part should be positive. Nothing but sigma y square into sigma x square minus what do you have here? Covariance of xy whole square. Covariance of x comma y whole square. So which is greater than or equals to 0. That implies sigma y square into sigma x square greater than or equals to covariance of x comma y whole square. So take the square root on both sides. Then what can you obtain here? Sigma x into sigma y greater than or equals to what? Covariance of x comma y. RS can write what? Covariance of x comma y is less than or equals to what? Sigma x into sigma y. Therefore, you can write down what? The covariance between two random variables is always less than or equals to the product of their standard deviations. And the next one is what? You have to study correlation coefficient. So, correlation coefficient. So, the correlation coefficient has been represented by the symbol rho. So, what is rho equals to? It is a ratio of covariance to the product of their standard deviations. What is the correlation coefficient formula? Rho is nothing but what? It is a ratio of what? Covariance of x and y to the product of their standard deviations. Whereas what is the other representation for covariance? Sigma xy. So sigma xy by sigma x into sigma y. Or else cxy by sigma x into sigma y. And therefore this is a correlation coefficient formula. And always remember that this correlation coefficient is always from -1 to 1. That is nothing but what? Always the absolute value of this correlation coefficient value is less than or equals to 1. Or else can say it is what? The minimum value of correlation coefficient is -1. The maximum value is equals to 1. So therefore, we have seen today the expectation of multiple random variables. In the multiple random variables, first you have taken the case 2 random variables and then we have taken the n random variables. After that, we have seen correlation, covariance and then correlation coefficient. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.